Hi everyone. So this is a question from CSIR December 2018 mathematical physics. So the question given here is one of the eigenvalues of the matrix e to the power a is e to the power small a, where capital A is the given matrix here. Okay. So the product of the other two eigenvalues of e to the power a is what? Okay. So according to the question, one of the eigenvalue of this matrix e to the power a is given, and what is the product of other two matrices? Okay. Let's how to solve this. So according to this, we have to write what is the given matrix, that is A matrix, and this equals to A 0 0 and 0 0 A and 0 A 0. So this is our given matrix. Okay. So it asks about the matrix that is e to the power a. Okay. So the eigenvalue corresponding this matrix is e to the power small a. This is one of the eigenvalue. Okay. So we have to know the rule that if lambda is the eigenvalue of a matrix A, then for the matrix e to the power a, okay, the corresponding eigenvalue should be e to the power lambda. Exactly, we have to find out what? We have to find out the eigenvalue corresponding this matrix. Okay. So how to find the eigenvalue? We have to write the characteristic equation, that is a minus lambda determinant should be equals to 0. Now find the value of lambda. How? So a minus lambda 0 0, again 0 minus lambda a and 0 a minus lambda, the determinant should be equals to 0. Okay. Now we will solve this matrix. Now how to solve this? So a minus lambda into minus lambda that is equals to lambda square, and this is minus a square. So this is equals to 0. That means a minus lambda into a square minus lambda square, sorry, this is lambda square minus a square, this is equals to 0. That means a equals to lambda, or from this lambda plus a into lambda minus a equals to 0. That means here a equals to plus lambda and minus lambda also. Okay. So that means what are the values of eigenvalues? So what are the values of lambda? Lambda is a and minus a. Okay. So what is the eigenvalue corresponding to the matrix e to the power a? Okay. The eigenvalue corresponding to the matrix e to the power a should be written as e to the power small a, e to the power small a, and e to the power minus a. Okay, these are the eigenvalues corresponding to the matrix this e to the power capital A. Okay, here also given this is one of the eigenvalue. What is the product of other two eigenvalue? That means we have to find the product of these two values. Okay, so e to the power a multiply e to the power a, and this is equals to 1. So 1 will be the correct answer for this question. Now come to another question, that is question number 22. The question is given as the polynomial f of x is equals to 1 plus 5x plus 3x square. This is written as a linear combination of the Legendre polynomial. Okay, so the Legendre polynomial form is given summation of cn pn of x. Okay, so what is the value of c naught or c0? Also given the values of p0, p1 and p2 also. Okay, so how to solve this? This is very easy questions. So we have to write down first of all the function given. What is the function f of x given here? So the f of x is given as 1 plus 5x plus 3x square. Okay, okay, as it is given that p naught of x equals to 1, p1 of x this is x, and p2x this is half 3x square minus 1. Okay, so from this equation I can find what is the value of 3x square. So 3x square equals to twice of p2x, that means 2 of p2x minus 1, this is plus 1. So 3x square value I just found. So now putting these values in the above equations. So this equals to, so instead of 1 I am writing p naught x, okay, plus 5 into, instead of x I am writing p1x, and plus 3x square I am writing 2p2x plus 1. Now p naught x plus 5 p1x plus 2 p2x plus again 1, that means again p naught x, okay. So p naught x and p naught x, this is equals to 2 p naught x plus the rest of the things, but we don't need to write any of this, because the question asking about what is the coefficient of c naught, okay. So as the Legendre transformation given here, that summation of cn pnx, okay. So here for c naught the transformation should be c0 p0x. So c0 is the coefficient of this one p naught x. So here the coefficient of p naught x is what, 2. So here the answer will be 2. This is equals to c naught.